I'd like to just explain to you a little bit about the formation of the sea of sand that we have in the Namib. What you can see now is just an overlay of a map, the sea of sand. We're just going to draw the rest of Southern Africa in here to give you a bigger perspective of where we are. We'll have Namibia over here. And we'll have South Africa below, Zimbabwe, Botswana and Mozambique on the outside. We are here in Swakopmund, and we've got a very small slither of dune field that you see here that's only 30 kilometers long, 5 kilometers wide. This is the major sea of sand, which includes Sossusvlei and Deadvlei, which goes into the south of the country and into northern South Africa there. So the beginning of the sea of sand that you see here today is in South Africa. We've got a very big mountain range here, known as the Drakensberg. And off the Drakensberg come lots of rivers and streams. The main river forming that we have to do with today is the Orange River. So millions of years worth of sand and sediments eroding down the mountain range into the Atlantic Ocean. In the Atlantic Ocean, we have the cold Benguela current that keeps the ocean temperatures between 10 and 14 degrees Celsius through the year. So in the south of Namibia, we've got a little town called Ludritz Bay. Offshore from Ludritz, we have the South Atlantic anticyclone that generates the southwesterly wind 90% of the year along the coast of Namibia. So what happens? Sand is forced out into the ocean. The Benguela current takes that sand and forces it back onto the beach. So effectively you have a dune forming in the south of Namibia, but that dune must get to where it is today, and it is taken there by this anticyclone. So that anticyclone picks up the dry sand, slowly forces it inland over time. If you look at these dunes here, these are long lines of dunes. You can actually think of those as waves in the ocean moving inland with a ripple effect in this direction, until there is a natural boundary in the eastern side. This is known as the Central Plateau, or the highland of Namibia. You can think of this as a wall going from south to north of Namibia. From the wall to the coast, there's a drop-off. So that'll be the definition of the whole coast from south to north, a very gradual slope. Off the drop-off is where we get all our dry river systems. It stops at the Central Plateau, the sand that moves with the wind. It cannot go any further, but it has to move somewhere. So this sand is still moving in a northerly fashion. It stops at the northern boundary, which is the dry Kwisep River system. And like all the other dry rivers, this only floods every 3 to 7 years. The river flushes and it takes down all that water back into the Atlantic Ocean. So this is an overspill of the major sea of sand. Eventually this should fill up. It will close off this Kwisep system. It'll look like a cut line, like the Tsondap River and the Tsauchap River. Eventually, the Swakop River will be the northern boundary. And then another dune field will start north of Swakop. It will fill up along the Omaruru, and eventually the Omaruru will take on the northern stance. The only time it will stop is when the source is finished. If the Drakensberg is completely flat, there will be no sand to send to grow our desert. But that's not a possibility in our new future. The Drakensberg is still very large. The oldest dunes are actually at the Namib Desert Lodge. Those are the petrified or fossil dunes. These are between 80 and 100 million years old. They reached the plateau first. They stopped there. With the press of water coming down the plateau over millennia, it pressed those into sandstone. So therefore now we have the fossil dunes, which are stable, and on the coast we still have the moving dunes.